not be formed and they start bleeding. No, it start bleeding. So that's a problem. INR might go, APTT might go up. So this is a problem. And the storage, I said liver failure might precipitate hypoglycemic attack. This is the reason. Glycogen storage is less, and then new glucose will not be produced to the circulation and hypoglycemia. And apart from vitamin A, D, E, K, and B12, all are produced in the liver. So if there's a problem with the liver, coagulation problems. Iron and coppers are also stored in the liver actually, right? Now if now excessive iron and the copper will be produced, will be stored in the liver and in some diseases. Copper is what is Wilson's disease. Iron deposited in the excess amounts in thalassemia, like with multiple transfusions. So the excess amount, but generally, usually they certain amount they store, right? In pathological conditions, it may be higher. And detoxification does from the portal system actually. And the one important thing is there are lots and lots of things. For instance, you need to know the phase 1 reaction, phase 2 reactions, okay, of the metabolism. I think is related to the pharmacology, right? And the other thing is uh, urea. Now, ammonia, which is produced in as a byproduct of the ammonia amino acid production or the protein metabolism, is toxic. Is toxic, and is not water soluble. And in the liver, urea cycle um, uh, convert this into water soluble urea and secreted in the urine. So that's called urea cycle. Okay, and immunological functions will be done with the Kupffer cells. Okay, so those are the. I mean, you can add some of the things, right? Understand? When you come across, I just wrote these things, but I think there are other things as well. Right now, the structure of the Now, in the liver cells, you need to know the structure basically. In a simple manner, you should be able to draw it so you understand everything. Understand? There's no point otherwise. Right? Don't open it cramming. Now, in the liver cells, there are acini and sinusoids. I will tell you. Let me show you that. These are actually acinus is the actual. This is one to the. Now, this is the portal triad. Portal triad means the hepatic artery, bile duct, and the what is the other thing? The what is the other thing? Yeah, hepatic artery, portal vein in the this one, portal vein, hepatic artery, and the bile duct. Okay, that's the portal triad. It's here, and this part is the lobule. This part is the anatomically lobule. Anatomically, we consider about the functionally acinus. The reason is actually acinus is this part. There are three zones, one, two, three. This is the central vein. Now, vein has less oxygen. No? So this part 3, can easily become hypoxic because the oxygen comes in this direction. Okay. So as a result, if the liver necrosis to a certain for instance, if the patient is hypoxic, rather hypoxic or hypotensive, let's say hypotensive, liver necrosis starts at this around the central vein because already this has a low oxygen. Okay, right. That's the point that I wanted to highlight. Again, you go back to your portal triad and the central vein here. Okay. Now the portal triad, and then let's say gut wall, uh, get your whatever the things that you eat comes in this direction and sending to the this direction. Okay, to the veins basically, and to the heart. And so that is so this is the pathway. Okay, on the other hand, this hepatic artery supplies blood to the arterial blood to the cells. And the bile, on the other hand, comes in this direction, other direction, and goes to the stomach, the intestine. Okay, so these goes to this direction, this goes to this direction, and these are sinusoidal cells. Sinusoidal cells. These are sinusoidal cells, right? Now here, of course, generally oxygen supply from this end now. So as a result, by the time this the arterial blood comes here, it becomes veins, venous blood. Okay, so venous blood basically is hypo. So this area zone 3. This is zone uh, B and this is zone A. Right? Okay. Zone 1 and 2. Sorry, zone 3, zone 2 and zone 1. Yeah. So zone 1 is relatively they have a lot of oxygen, won't happen. So if your blood pressure is down, this part will be first necrosed, this part, and then this one and the other one. Okay. Okay, this is the, I told you, right? And yeah, zone 1, this is the zone 1. These are rich in blood, highest oxygen concentration. Okay, and zone 2 in intermediate zone. Zone 3 centrilobular. Lobular එක මැද තියෙන්නේ least oxygen, high concentration of cytochrome P450 drug biotransfer utilize glucose, right? This is area which is the glycolysis at the same, but it has high concentration of cytochrome P450, right? So, which I told, this is the thing, hepatic portal vein, hepatic artery, and this is the other side, hepatic vein. Okay, this is the design. These are hepatocytes, and on top of that, you can see the sinusoidal cells as well. These are hepatic cells, hepatocytes, and these are sinusoids cells. Now here, blood flow. This also will be asked in your exams. You know how much blood flow liver receives. So 1.5 liters per minute. That means 25% the cardiac output. Okay. We asked this time from the surgical people the related to the brain actually how much blood your brain gets. Most of the people didn't answer, right? That is a bad thing, right? Basically, you need to know, right, these kind of figures. Uh, Reservoir is a 450. At a particular time, liver inside has 450 ml blood, like half a pint, like, isn't it? Half a liter, like. Hepatic now blood supply is actually at a particular time, hepatic artery supply, that's oxygenated blood, 30%. Okay, so that is dependent on the systemic pressure. If your pressure is down, that will be cut off. And the portal vein, the vein which carries gut related blood that has nutrients, 70%. Okay, this is usually in a fed state. කාපු වෙලාවක තමයි මේක. Fasting states actually hepatic artery portion becomes higher, portal vein becomes portion will be less than this. Okay, so that is the, and the inside the sinusides and this the structure, pressure will be very minimal, 2 millimeters mercury generally. Okay, right. Now about the intrinsic control of blood flow. Intrinsic control of the blood flow. Now there's a thing called autoregulation, right? Autoregulation and the portal vein. Now portal vein, this is let's say this one, portal vein, right? Okay. Portal vein. This has no autoregulation, right? This has no autoregulation. Right. Autoregulation, hepatic artery has very good autoregulation. When pressure reduces, flow is maintained by the lowering resistance. Okay. That's autoregulation. And portal vein has no autoregulation, right? Intrinsic control. Now, there are, when you talk about the autoregulation, you're talking about the myogenic response, metabolic response as well, no? Now, the myogenic response is actually increased hepatic venous pressure, increases the hepatic arterial resistance, and decrease the hepatic arterial blood flow. So what happens is If your liver is congested, venous pressure is high, that invariably exert a pressure on the arteries and they will be constricted, then arterial blood supply will be reduced, right? Metabolic response is that this is the another thing, important thing which will be asked in the exam. What is hepatic arterial buffer response is? Now, if the intrahepatic adenosine, that is, if the patient's liver is little bit hypoxic, adenosine will be increased and blood flow, reduced portal blood flow, and sorry, the adenosine build up hepatic arterial vasodilatation, right? Adenosine is a vasodilator, right? So what happens is that if you're not getting uh, good supply from the portal blood, right, in a fasting state, and then adenosine will be accumulated, and as a result it will increase the diameter of the artery, hepatic artery, and blood supply of the hepatic artery will be higher. Then of course that will be the adenosine, that is called hepatic arterial buffer response. Otherwise liver won't get the blood, no, because 70% is from the mesenteric portal blood flow. Okay, so that should be reversed in a fasting state by the adenosine mainly, and some other vasodilators as well, which are accumulated in the vessels. Okay. Extrinsic control, outside control to the arteries actually, alpha and beta adrenergic receptors and dopamine receptors. And portal vein also, now understand, portal vein, they have extrinsic control. This has no capacity itself to do something, dilate and vasoconstrict. That's auto-regulation. But externally, you can have alpha adrenergic and dopamine receptors are there to constrict the things. Okay. So that's it, right? Um, And another topic is actually the next our next topic. So we were talking about the GIT and the liver. Okay, what happens there? And the next topic is actually coagulation. I think part coagulation, clot, the cascades and thing we need to describe. We will now 9:36 in 3-4 minutes we will start at 9:45. Shall we start at 9:45? Okay, little break. Okay, otherwise you will sleep and I also might sleep. Okay, okay, in 45. Okay, start at 45. Okay. Shall we start? Okay, we start, right? Um, can you hear me and see the screen? Hello? Hello? We'll start, right? Can you hear me
Yes, sir.
and see the screen?
Yes, sir.
Okay, right. In your audience, there are two Korean people actually, isn't it? One is Samsung something, other one is other Samsung, right? Right. Anyway, the right. So we'll go like this. Hemostasis.